How are you, everybody who is in this class? I'm very happy to have you today. My name is Olenjolai, TAYAI Losingo. Just simply call me Olenjolai from one of the beautiful countries that called Tanzania. And today I have a good news concerning about the chemistry for all level, for ordinary level. But because I talk about what I've prepared for you, I would like first of all to welcome you into one of my online school. This is an online school. It's not a physical school. That's called the Tanzania Online Ordinary Secondary School in square bracket Olenjolai. In near future, you will access the contents of these schools in different online platforms, but currently you can access in this YouTube channel. It's called the Tanzania Online O-Level Secondary School in square bracket Olenjolai. So when you get into this channel, you'll see so many videos we have recorded when we are teaching and training the O-Level students from the Form 1, Form 2, Form 3, Form 4. Well, chemistry actually is a universal subject. What does it mean? That in different countries, in different continents, students used to learn about chemistry. And good enough, in Tanzania, we didn't discover anything else about chemistry, but we have accepted what other scientists or other chemists in the world have discovered and published, and also we have to learn. But we still have a hope that maybe in present or future generation, maybe some of the Tanzanians can break the history or create a new history that to the new discoveries in chemistry. Possibly there are some of them, but maybe they are not popular enough so that to be noticed worldwide. But one thing I want to tell you that in Tanzania, even the names of the schools is called Tanzania Online Ordinary Secondary School. We are focusing on the syllabus of the Tanzania educational system for ordinary secondary education. And this syllabus has been prepared by the Tanzania Institute of Education, which is in short we call it TAYAI, or most people they used to call it TAYAI. However, that these contents may be relevant for any, maybe class, because this is class 10 or class 12 students, maybe in Kenya, in Uganda, because the stuff, for example, oxygen, this is a subject which is used to be learned worldwide according to my research. So whether in America or in any African continents, in Nigeria, they're always learning about oxygen. So nothing new. But in Tanzania, just we use our syllabus used to recommend some few issues in order to teach our students at the second class of ordinary education. Again, I know that it may be, I know that most of the Tanzanians, even myself, I used to learn my ordinary secondary education physically, where I have an opportunity to ask questions when I will be given a chance by the teacher who is leading the class. So in case of the online, you can be worried about how can you answer questions. The good thing is, for example, the current platform that you're using right now, which is YouTube, it has sections of the comment section. You can ask your questions, you can establish the group discussion. It's below here, just so you can see it when you're watching this video. So, and also you can submit your homework, because in every session, I'm going to leave the homework in order to make you active and make sure that I practice active learning, because that's what is changing the world right now. So I can have, I have a lot of information, but right now let us go into the class. Another thing is we need serious students. If you're not serious, this program will be not yours, because we are going to do great work and we have a lot of things to cover. For example, this is session 2. Actually, in ordinary schools, a teacher can cover the topic of oxygens in 2 sessions, 1 or 2 sessions, I know, because it depends on the style. We differ. We as teachers, we differ in the style of teaching, in the teaching aids, in the arrangements of the concepts, in the searching of the information. But really, I want to tell you that in these online schools, we are going to provide you what the syllabus recommend us to provide. And even sometimes we go extra miles compared to what you'll be given in your school. But don't throw anything else that you're learning in your class. You have to take care of them, and you have to also to supplement those contents with what we are teaching you. So you can take your exercise book, you can take your pencil, in case, because sometimes, I am teaching mostly students who are good in Swahili rather than English. And some of the terms, when I feel from my heart, I can pronounce them just I can define them in Swahili language. So you should have your pencil in order to write down definitions of the some terms. Should have your ruler, should have the book. But beside you, I recommend you should have at least one reference books for chemistry. For example, this one is called Chemistry Form 1 and Form 2 students book. And also, this is a textbook because you have textbook and you have questions. I recommend also should have a Form 2 chemistry review books because from today in this session, we are going to refer some of the questions from the past paper, the NECTA Form 2. But later on, we will recommend you to have a review for the Form 4 if you're a Tanzanian student. If you're a Kenyan student, I think that also you can refer questions and answers or any Kenyan chemistry Form 2 review book because actually what they will ask you is not different from what we used to ask our Tanzanian students. So if that's the case, I think that you are ready. I believe that right now you are ready. So let us go into the class. So I said we are in departments of chemistry. So the subject is chemistry. This is chapter 1 of the Form 2. It's called the oxygen. Say oxygen.
Oxygen.
Okay, so this is session 2. What is oxygen gas? So today I have actually a serious business on telling you what the means of oxygen gas. However, that in session 1, I discussed and defined oxygen as an element, but here we have to learn oxygen as a gas. This content is dedicated for the pre-Form 2, Form 2 student, Form 4, or in other educational systems, you call it class 10 and class 12. And you have to be happy when you are learning chemistry. You should not just angry and ugly. Chemistry is not like, just like maybe wrestlings or some other activities or some other issues that when you are learning, you have to emphasize your mechanical activities. This is actually that you have to use your intellectual, your brain, and things will be okay. So the quick review of session 1. Okay, quick review of session 1. So in session 1, if you do remember, I began with the big picture. Say big picture. So the big picture of chemistry first, because I remind my students where chemistry comes from. Because if we discuss about chemistry itself, then without having the big picture in our mind, we find that chemistry always is our strength or is our foray. So chemistry always becoming a new vocabulary, while chemistry should be a normal vocabulary. So we had a subject called science during our primary education. So when we get into O-level educations or ordinary level education, then this subject of science is divided into 3 main branches. This is when you are in ordinary secondary school. So we have physics as one of the branch. We have also chemistry as another branch of science. And also we have biology. So if you categorize this subject of chemistry again, when you get into the ordinary education level, we get 4 subjects in O-level. Okay, we get 4 subjects. So the first subject is chemistry Form 1, which I'm also teaching you, chemistry Form 1. And then the second subject is chemistry Form 2, which we are learning right now, chemistry Form 2. Then the next subject is chemistry Form 3, which I'm teaching you also in the same online platform, chemistry Form 3. And then the next one is called the chemistry Form 4, chemistry Form 4. The good thing, I used to teach chemistry Form 1 in 2 languages, in English and in Swahili, in order to transform especially students who come from Swahili educational system. So when you go into the chemistry Form 2, please, I ask you to write this in your mind and write it on your copybook because it will give you the overview, the general overview. I want this picture to be written in your mind permanently when you have this journal of chemistry. So this is 4, and this is 5, and this is 6 and 7. So for the chemistry Form 2, we have 7 topics. We have to cover only 7 topics, which actually are not a great deal, but they are foundational in entire chemistry, whether O-level or A-level or whatever. Okay? So the first topic is called the oxygen. This is the first topic that we have to learn. It's called the oxygen. The second one is called the hydrogen. So I'll be writing just the letters, hydrogen. And then the third topic is called the water. And then we have sources of energy, that's the first topic, sources of energy. Then the fifth topic is called atomic structure. And the sixth topic is called the formula, bonding, and the nomenclature. So formula, bonding, nomenclature. Okay? Nomenclature and nomenclature. Then the seventh chapter is called the chemical bonding. Let me repeat lastly. The first chapter is called what? Oxygen. The second chapter is called what? Hydrogen. The first chapter is called what? Water. The first chapter is called what? Sources of what? Of energy. Then the fifth one is called what? Atomic structure. The sixth one is called what? Formula, bonding, and the nomenclature. Then the last chapter is called chemical bonding. Well, so that's all about what we discussed. So in case you missed this, because I spent almost an hour, I think, yes, an hour, almost an hour. I think that more than 40 minutes to explain this in detail, reference books, what the syllabus, what are the specific objectives. So I spoke a lot about this, and then as I discussed the first chapter, which is oxygen, and what we should cover, what are the specific objectives, what are the contents that recommended for you to cover. So today, let us go to the terminology which I've written there as oxygen gas. We defined oxygen as oxygens, that is a chemical element that constitutes 21% of the Earth's atmosphere, that is capable of combining with all elements, except some noble gases. I gave you two definitions. The second definition, we say oxygen is a chemical element with a symbol O and the atomic number 8 found in group 6 of modern periodic table. So that's what we defined. So so we say that oxygen was discovered about that. That's what we've discussed. And today let us go into into these questions, into this fundamental question. What is oxygen? What is oxygen gas? What is oxygen gas? Okay, what is oxygen gas? So I found one of very interesting definition, and this one. Oxygen gas, we say that is a colorless, odorless, tasteless, and tasteless gas, essential to living organism. Essential to living organism, being taken up by animal like me, animals, conveyed it into carbon dioxide. So before I explain this one, okay, that's one of the definitions. So say oxygen gas is a colorless, does not have any color, is odorless, does not have any odor, odorless. Here we have odor, is odorless, and tasteless, it does not have any tasting. Okay, if you test it, it's essential. But regardless of not having color, not odorless or not odor, and not tasteless, or regardless that it is a colorless gas, odorless gas, and tasteless gas, but it is essential to living organisms, especially what? Animals, because it is being taken up by animals like me and you, and these animals are used to convert it into carbon dioxide. So this is one of the definitions of oxygen gas. What does it mean? First of all, oxygen does not have color, does not have odor, does not have any taste. But we as a living organisms, according to another branch of science that called the biology, we have a process that we call taking in the gas and taking out the gas. It means breathing in and breathing out. So when we breathe in, we are taking in what? Oxygen. And then the metabolic activities take place in our bodies. And when we breathe out, we are giving out what? Carbon dioxide. So that's the meaning of this definition. That regardless of all of those things that we say, maybe oxygen is green, oxygen is blue, it does not have any color. Regardless that maybe you say that oxygen is bitter, oxygen is sweet, it does not have all of those characteristics or properties. But it's essential for the life of living things. If we stop on breathing in the oxygen, then we are going to die. Right? So it's essential for living things. Why? Because we take this gas and convert it into carbon dioxide. Remember that plants actually that they need oxygen, possibly they don't need that oxygen as how we need, but plants need too much carbon dioxide. But plants used to give out oxygen, right? So used to take in oxygen and we take out carbon dioxide. While plants used to take in carbon dioxide and give out oxygen, right?
Yes.
Yeah. So plants utilizes. So we say that plants, because plants is the one is among the living things. Okay, plants utilizes what? Carbon dioxide. Carbon dioxide. Plants utilizes carbon dioxide as a source. As a source of what? Of carbon. And we convert it into what? Oxygen. And give this out as a return of what has been taken. Okay, oxygen to the water. Okay, and they give oxygen into atmosphere. So that's the key point that you have to remember. Oxygen gas forms about 21% by volumes of the air. Remember that oxygen gas forms about 21% of volume, 21% of volume of air. So remember that it comprises 21%. So the remaining, which is almost 79%, is other gases that will be containing in the atmosphere. So that is. So remember that, so it means oxygen form about this one. So oxygen gas, the word oxygen gas is also called oxygen. So whenever you hear the word oxygen, we mean that it is oxygen gas. So you can call it oxygen gas, or in some of the books we just call it oxygen. Okay? Okay. The symbol. So why are we using the word oxygen gas? Because we want to differentiate oxygen gas from oxygen element. Because we have an element which is the 8th element in the modern periodic table. If maybe you want to mention the first 20 elements in a periodic table, then oxygen is number 8. So that's oxygen atom. I'll remind you about the existence of oxygen. So symbol of oxygen gas. So whenever I say oxygen gas, I insist about it. one of existence of what? Of oxygen gas. Okay? So you say that in the symbol of oxygen gas is oxygen, and then we have a subscript of 2. Okay, so this is the symbol. And the physical state of oxygen gas is, we use the small g, letter G, as to show the physical state of what? Of oxygen. Let me, I remember that I told you in session 1 about the existence of oxygen. But let me remind you, because that's very important before we proceed. Okay. So existence, so stay with me, existence of oxygen.
Existence of oxygen.
Or in some concept called allotropes of oxygen. There are 2 allotropes of oxygen, of oxygen. Okay. So we say that oxygen can exist in the following form. So we have 3 forms where oxygen can exist or can be extracted or can be prepared in the following forms. Oxygen can exist as monoatomic. Say monoatomic oxygen.
Monoatomic oxygen.
Say monatomic oxygen.
Monoatomic oxygen.
So this is what we call the oxygen element. Okay, or oxygen atom. So monatomic oxygen or oxygen as well. An element. Also, oxygen can exist as diatomic what? Diatomic gas. Okay, diatomic gas or diatomic oxygen gas. This is chemical formula is or subscript of 2, right? And also oxygen can exist as triatomic. So triatomic state. Triatomic state. Or triatomic oxygen. In other words, this we call the ozone oxygen or ozone layer, which existing in the atmosphere. So the molecular formula of triatomic oxygen is oxygen, and then just 3 elements, oxygen 3. So this is monatomic oxygen, diatomic or oxygen gas, triatomic oxygens or ozone layer or ozone oxygen. So we call it ozone oxygen or ozone layer. So ozone oxygen or ozone layer. So you'll hear it even in case of in the process of what? Of pollution. Okay. So in this session or in this chapter, we are going to discuss also a very important part that we call preparations of oxygen. We are going to discuss about physical properties of oxygen, chemical properties of oxygen, uses of oxygen. So you have to stay tuned. In other session, we are going to teach you some other concept. So because we are still teaching you what is oxygen gas, because we have just touched here and there about oxygen gas, but you are the Form 2 students according to the curriculum. You have to go to the laboratory and prepare the oxygen gas. Okay. So now, ladies and gentlemen, let me teach you about preparations, laboratory preparations of oxygen. Say with me, laboratory. This is a very important part, and I will show you some questions which have been asked in Nectar Form 2. Okay, laboratory preparation. This is one of the very important topics in Nectar Form 2 because it used to contribute a question before 2010. It used to contribute question 10. So question 10 in Nectar Form 2 is questions about oxygen and hydrogen. Nowadays, from after the format of the exams has changed from 2012 onwards, then you find that now question 9 or question 4 depend. But in every Form 2 NET exam, you'll find at least one question about oxygen and one question about hydrogen, so the special laboratory preparation, right? So laboratory preparation of oxygen. So remember that in most cases, we use the word oxygen rather than oxygen gas. Manake, let me just translate this in Swahili to help also who didn't catch up in English. Kuna tofauti ya oxygen atom na oxygen gas. Sawa? Lakini tunapozungumzia oxygen tunamaanisha oxygen gas kwa sababu ndio ambayo tunakuwa tunahitaji. Tukitaka kuzungumzia oxygen element kama atom ambayo ni hii monatomic, tutasema oxygen element. Tukisema oxygen element maana tunazungumzia nini? Tukizungumzia oxygen gas maana tunazungumzia nini? Diatomic oxygen, au badala ya kutumia oxygen gas tunaweza tusitaje au tusiongeze hicho kivumishi cha gas tukasema oxygen. Yaani tukisema oxygen maana tunazungumzia oxygen gas. Yaani simply remember that I said here, oxygen forms that one. The word oxygen gas is also called oxygen. So it means that the word oxygen gas and oxygen are used interchangeably. When we mention oxygen, we mean oxygen gas. When we want to mention oxygen atom, we have to say oxygen atom or oxygen element, which we mean about what? Monatomic. And in oxygen, in this chapter 1, we are going to discuss oxygen gas. Yani topic hii au mada inazungumzia oxygen gas. Haizungumzi element ya oxygen. Kwa tunaposoma periodic table, tukaona oxygen kama ni element ya 8 katika periodic table katika zile element 20. Manake tutazungumza sasa oxygen atom. Hiyo inaita oxygen atom au oxygen element. Sawa? Kwa hiyo utakapoona naposema laboratory preparations of oxygen, usidhani kwamba tuna prepare oxygen atom. Hapana. Tuna prepare nini? Oxygen gas. Yaani ukiona neno oxygen kwenye topic hii maana yake ni oxygen gas. That's the meaning. So whenever we use the word oxygen, translate in your mind we are talking about what? Oxygen gas. Let me repeat. Whenever you see the word oxygen in this chapter, oxygen, this means about what? Oxygen what?
Yes.
Gas. Only in this chapter. Right? And this means about what? Diatomic. Diatomic what? Diatomic oxygen. And this means about what? Oxygen, which contains two atoms, which is called oxygen molecule. Are we together? So bear that in your mind. So when you say laboratory preparation of oxygen, you may say laboratory preparations of oxygen gas. And you may say also laboratory preparations of oxygen as oxygen. So in order to avoid confusion at the beginning, you can say that the laboratory preparations of oxygen what? Gas. Which its chemical formula is 2 molecules of what? Of oxygen atom. Are we together? This is very important point. Because we can dig in detail about oxygen, but the syllabus tells us should not spend much time to tell you about what the means of oxygen, but you have to spend much time to teach you how we can prepare oxygen. Because we say in definitions of science, we say that this is experimental, this is a theoretical and experimental science. Okay, so laboratory preparation, say laboratory preparations of oxygen.
Laboratory preparation of oxygen gas.
So we say that oxygen gas can be prepared in school laboratory, in school or home or industrial laboratory by using different methods. So we have different methods of preparing what is oxygen. So oxygen gas can be prepared. So we can prepare this. So if you're in school laboratories, if you go to school tomorrow, you can ask the lab technicians to give you the materials and apparatus, and you can prepare the oxygen gas and can test it, right? It's your right. If you have materials, you have a chemistry lab, it's your responsibility to go there and do experiments and learn chemistry experimental, right?
Yes.
So it's not, you have just to follow the rules of chemistry laboratory, that's all, in order for you to be safe, to protect yourself or to be safe. Okay, so he said that by using different scientific methods, so the choice of the particular case, so method of okay. So by using different scientific methods, these are scientific methods, not the literature methods, scientific methods, so just that one. So if that's the case, so now we have to go to another concept. So you have different ways or different methods of preparing oxygen gas in lab. When you say there's a school lab in every school, and even our country right now has a great policy after building the classes, there's a great policy of building laboratory, which is chemistry laboratory, biology laboratory, and physics laboratory. But even if in a school, maybe you have a single lab which contains physics apparatus and laboratory equipment, and the chemistry and the biology, don't worry about that. Just use the material which are there, because the government is paying a lot of money for you to experiment in chemistry. Don't worry, because I'm going to teach you, and don't worry that everything is going to be right. And if you test, because this is the work from the laboratories, you are going to enjoy. But you can have your chemistry lab at home. You can have also the chemistry lab in industry, in colleges, in universities, in research centers. So we have so many different laboratories of chemistry, right? Okay, so in TBS, for example, if you go to TBS, Tanzania, or in TBS, you can find there's a lab in actual that in National Chemistry Laboratory. So we have so many different laboratories. So we say that now, ladies and gentlemen, let me teach you about different methods. We say that we have different methods of sorting, of preparing, different methods of preparing water, and method of preparing water, oxygen in laboratory. We mean oxygen gas, not oxygen atom in laboratory. So as I say that, we say that there are different ways of preparing water, different scientific methods of preparing oxygen, right? So then we say that the choice of the scientific method used to prepare oxygen depends on the quantity or amount that you want to collect. So I'm going to mention 4 common methods of preparing oxygen in school laboratory. But the choice of whether you use the first method or second scientific method or third scientific method or fourth scientific method depends on the amount of oxygen that you want to collect. So if you say that in first scientific method it depends what amount that you want to collect. So we have so many different ways of preparing. So some of scientific methods that are used to prepare oxygen in laboratory are the following. The first one can prepare oxygen by decompositions of hydrogen peroxide by using manganese 4. So the first method is by decomposition. Say decomposition.
Decomposition.
Compositions of hydrogen. Say hydrogen peroxide.
Hydrogen peroxide.
Say hydrogen peroxide.
Hydrogen peroxide.
Okay, so the compositions of hydrogen peroxide by using manganese, manganese 4 oxide. This is the first method that we are going to discuss. And it's a very interesting method, and it is common method, and this you have to learn this method as a Form 2 student or as ordinary level student, because at least you have to know 2 methods, the first 2 methods that the syllabus would recommend. So the syllabus recommends us to teach you how you can prepare oxygen from decomposition of hydrogen peroxide by using manganese 4 oxide. And you have to stay tuned, because I'm going to teach you how we achieve or how we collect it or how to prepare oxygen by using this method. That's the first one. So the composition, so hydrogen peroxide will be our reactants, and then manganese 4 oxide will be used as a catalyst. Possibly you don't know the meanings of the catalyst, but soon I'm going to define, or when I'll be teaching about the composition of hydrogen peroxide, I'm going to define the meaning of the term oxide, or the meaning of the catalyst. Because catalyst actually speeds up the chemical reactions, but itself is not undergoing any chemical change. That's the meanings of the catalyst. For example, in biology, we used to say that when you want maybe the digestive system to take place, we need something called the enzymes. So enzymes act like a catalyst. For example, if you want the digestion of carbohydrates to take place, we need saliva enzyme, right? In order to speed up the digestive process or the breakdowns of that food that you've taken. So chemistry is beautiful. You have to keep on enjoying it. The second method, we can prepare it by semi-decompositions of certain salts. Okay, so let me test it to, I think that, okay, should I give you the, okay, I'll give you later. So decomposition, so semi-decomposition, so this is now semi-decomposition. Semi-decomposition. Say semi-decomposition.
Semi-decomposition
of potassium chlorate. Potassium chlorate. So potassium chlorate or potassium nitrate. Potassium chlorate or potassium nitrate. We are going, the good news also, the syllabus and even some of the past paper questions, they recommend us as teachers to teach our students how we can prepare oxygen in school laboratory by using the method of semi-decomposition of potassium chloride. So because we are not going to study how we can prepare oxygen from the semi-decomposition of potassium nitrate, but it's the same method, but what you have to change is just the reactant. So I'm going to give you the equation for the potassium nitrate, because the equation for the potassium chlorate, I will give you the chemical equation, the chemical weight equations and the chemical balanced equations when I'll be teaching you about semi-decompositions of potassium chlorate, because this is the session. This is the session, and I saw it in many nectar, in many Form 2 nectar past paper being past papers. Okay, you have a question? Ask your question.
Number 2.
Huh?
Number 2.
Number 2, huh?
Repeat in Swahili language.
In Swahili language.
Yeah.
Thermodecomposition. Thermo means heat. Heat decomposition. We decompose, tunaivunja potassium chlorate ambayo ni chumvi, ni salt, au potassium nitrate kwa ajili ya kuzalisha nini? Oxygen. Kwa hiyo hii ni njia mojawapo ya kuandaa oxygen katika maabara ya shule. Tutasoma inakuwaje, hii ikoje, chemical equation yake, hii potassium chlorate inaandikaje? We'll learn about that. I'm just introducing to you. So, the chemical equation of potassium of what let's say same decompositions of what of potassium nitrate. So, if we want to learn about same decomposition, same decomposition of what? Of potassium what? Potassium nitrate. This we say that the word equation will be what? Will be potassium nitrate. Potassium nitrate. This one, because we need heat, so you can use heat of the weights, or you can use this symbol representing heat, this triangle. So when potassium nitrate decompose, it gives us what? Potassium nitrogen dioxide. So you get potassium nitrogen dioxide plus what? Plus oxygen gas. So this is the word equation. Hii ni chemical equation kwa maneno. Hii inaitwa reactants. Kumbuka kwamba, let me remind you that in chemistry we have something that we call reactants on the left hand side, vitu vinavyo react au vinavyoungana au vinavyovunjika. Alafu hapa kwenye mshale tunaweza kuweka kitu inaitwa catalyst. We are going to define what the meanings, or maybe condition kama heat or whatever. And then so on this side we have something called in chemistry products. Say products. Manake products na ile inaitwa reactants. Kwa kushoto reactants vinavyoungana, vinavyovunjika, what decompose, what combine, what undergo displacement. And then here we used to put the catalyst or the conditions, and then so produce something called the products. So we can have, in a chemical reaction, you can have either two reactants, you can have two reactants, or you can have three reactants, so it depends the type of the chemical equation. So for the equation above, the reactant is what? Potassium nitrate. That's the reactant. Wait. So the reactant is what? Potassium nitrate. And then the condition is what? Heat. And the products are two. The first product is what? Potassium nitrogen dioxide. And what? Oxygen. Yes. Okay, welcome. Have a question? Welcome.
I was asked about the potassium nitrate. The symbols of that potassium nitrate is A.
The spelling. Nitrate. You're asking about the potassium. Which potassium? This potassium nitrogen dioxide.
And the opposite.
This one. Potassium. So this is double S I U M. Nitrate.
The symbol, I mean.
The symbol.
Potassium nitrate heat.
Okay. Potassium nitrate. This is heat, or we can write the word heat, or we can use a triangle. That's the meaning. We can use a triangle. Whenever you see a triangle, that means heat.
No, that is A.
Not A. This is a triangle. This is a triangle, not A. You can, listen. In some of the equation, we are going to use heat as condition. Tunaandika neno heat. Au badala ya kuandika heat, tunaandika alama hii tukimaanisha. Ukiona hivi kama mwanakemia, hii maana yake ni condition heat. Kwa ni kipembe tatu. Right?
Yes.
You have to be open-minded in chemistry. This is how chemistry is getting changing, and it's very interesting. You have to keep on enjoying. But whenever you have any question, please ask it. I'm using English because that's the recommended language to teach secondary students from Form 1 to university level. So in Form 1, for chemistry Form 1, as I said, I'm using two languages, English and Swahili. So you might find, so if this is your first moment, you can find some challenges, but when you take the first session, session 2, session 3, session 4, session 5, as long as we continue, you will adapt and these things become simple and even learning process of you by using English becoming simple, and even yourself now you start speaking English while you have never attended any English course session, right?
Yes.
Yeah. So don't worry about using English. You have to, because if English is the international language. I know that also Swahili is international language, but it's spoken in Tanzania, in Kenya, in East Africa. Yes, I know even in Americans, in Europe. Even myself, I'm very good in Swahili language. But some of the terms is difficult to define them in Swahili language for chemistry, right?
Yes.
And so I know in school you used to learn by using Kiswanglish or Swanglish. Little English and maybe too much of Swahili. But that's not acceptable. When I will teach you in Form 3 and Form 4, I will never translate any terms unless I find this the completely a new term. Why? Because I believe that I taught you in Form 1, taught you in Form 2, taught you in Form 3. You didn't understand. When I say element will be a new term for you. No. There's no need for me to define what it means of element. When I'll be speaking about oxygen again, it will be a new, right?
Yes.
So from there you see, even myself now, even yourself, you can take some, you can learn some of the concept from different countries, from other teachers. So you find your process of learning becoming simple because you won't be depending on your local teachers, right? So you can go online, maybe you can learn some of the contents taught by the teacher from South Africa, from Nigeria, you see, maybe from America, from Europe. So you find even yourself that, you won't be just entertained, but even you understand the concept. Because if, for example, you go on YouTube, you'll find there's a special, maybe there's a video showing the laboratory preparations of oxygen, for example, the compositions of hydrogen peroxide,
Yes.
right? So you see, and even if you go to a school lab, you ask the lab technicians, don't wait until your teacher invites you to go to their school lab, right? Don't wait, because it might be a challenge because you have so many students. But you can go yourself and consult the lab technicians. I learned about laboratory preparations of oxygen, and I understood. Can you help me to prepare? I want to see oxygen, because it's possible, right? Because when we will be learning about properties of oxygen, we find that oxygen supports fire. Do you know about that?
Yes.
And carbon dioxide is just actually it's a fire extinguisher material, right? So it means that you can test it. When you collect the oxygens maybe in the gas jar, you just try to take maybe a piece of of the matchbox, right? Stick it from the matchbox, and then you turn it, and then you find, if you find that it means that the amount of fire is increasing, then you say, okay, what's it is here? Are we together?
Yes.
Because usually we used to, so okay, there we are creating something about the pressure. That's another thing, because we used to, maybe, for example, if you are using the charcoal burner, right? Or we call the wood burner, right? Or woody fire system. Then we used to, but actually there we used to compress oxygen, because ourselves we are breathing out carbon dioxide. Carbon dioxide is turning off is a fire extinguisher. Do you know that? Do you know that?
Yes.
Okay. So now we have, this is the way the question. We have on the reactant side we have potassium nitrate. Say potassium nitrate.
Potassium.
The chemical symbol of potassium is K, right?
Yes.
And then the chemical symbol of nitrate is N, capital N, O, and then 3. This is called the potassium nitrate, right? So when it decomposes under presence of what? Of heat, right? We get what? 2 products. Potassium, nitrogen dioxide. So potassium, the symbol is K. Then nitrogen dioxide, we have nitrogen. This is a symbol for nitrogen. Dioxide, we means 2 oxygen atoms. So it means that the oxygen gas also equal to dioxide, right?
Yes.
In other words, we call it di. Di means 2. Diatomic. So dioxide is come from the term diatomic. Diatomic means 2 atoms. So when you say potassium, nitrogen, dioxide, so this is in nitrogen. Dioxide, we means 2 atoms of what? Of oxygen. Dihydride, which means 2 atoms of what? Hydrogen. Are we together? Welcome.
What about potassium nitrate? This
Potassium nitrate?
the
symbol. Okay, nitrate. These are the word nitrate. I know this is the new term for the form 2 or the form 2. Say nitrate.
Nitrate.
This compound, nitrogen, when it combined with 3 atoms of oxygen, form a compound we call it nitrate. So K stands for what? Potassium. And then 1 nitrogen atom and 3 oxygen atom form what? Nitrate. So this is a compound. It's not an atom. Nitrogen is an atom. Oxygen is an atom. But here now we have a compound. So what means of the compound? This is a one compound. Even if also potassium nitrate, this is a compound. Are we together?
Yes.
So this is the compound. This is the element. When element combined with the compounds, we form a compound. You have to attend by sessions of compounds because we say we have what? Informal, and we have also about we have discussed about compounds, air, combustions, and whatever. So we say we have 2 products. Nitrogen what? Potassium. This is what? Potassium, nitrogen dioxide. Plus what? Oxygen gas. What the symbol of oxygen gas? Do you remember?
Yes.
Oxygen and then subscript of what?
3.
Subscript of 2. Oxygen gas. Oxygen gas. Remember, just to check your notes. Go back to your notes. The symbol for oxygen gas.
Yes.
Yeah. So not 3. 3, that is triatomic. We call it ozone. Ozone oxygen. Ozone layer. But this is not the ozone layer. Don't confuse. Ozone oxygen is when we have 3 atoms of oxygen themselves. Right? But here, this is not ozone. This is nitrate. Are we together?
Yes.
Yeah. So you have to avoid. And also, this one, this now is a compound. It's a one compound. It's called what? Nitrogen dioxide. So this is not oxygen gas. Why? Because there's another atom again. So the oxygen gas is when we have O itself, oxygen itself. Are we together? I know that is something confusing in your mind, but don't worry. Stay tuned, you will enjoy and will be a master of this stuff. Tell yourself, I'm going to be a master of chemistry from 2.
I'm going to be a master.
Yeah, so you have to tell yourself every morning, I'm going to be a master of chemistry from 2. I'm going to be a master of physics from 2. I'm going to be a master of basic mathematics from 2. And then you get surprised.
What the heat help the needle?
Yeah, heat is to speed up the decomposition. Decomposition means breaking down. For example, this is the piece of chalk, right? If I want to decompose it, so I decompose like this. So before it was one piece of chalk, right? And then now by using my hand, I decompose. So the function of heat, what the heat? The heat is actually influencing the decompositions to be fast, right? So for example, if I give a child to break this piece of chalk, he or she might spend long time. Why? Because of the strength of his or her hand, right? But myself, you assume that this is the potassium nitrate, and then myself act as heat. So I decompose it. Once I decompose, before it was this kind, right? Before it was one product, one reactant. So we call it potassium nitrate, right?
Yes.
Then we heat it by using a Bunsen burner in laboratory. You know the function of Bunsen burner?
Yes.
So we heat it. Once we heat it, this decomposes and form what? Potassium nitrate of this piece of chalk and what? Oxygen. Are we together?
Yes.
But remember, this is one direction. It's not a reversible reaction. This and this cannot react to form this. But this can react to form this and this one. It's one directional. Later on, I'll teach about reversible. When we get into form 3, we have reversible, or we call it chemical equilibrium. We'll teach you some of the reactions that the reactants breaks to form product, and products combine to form what? Reactants. Are we together?
Yes.
So bear in your mind, potassium nitrate was like this. We heat it and then decomposes. We form potassium what? Nitrogen dioxide. and what? Oxygen gas. Are we together? I believe that you have understood, and it will be difficult for you to forget that demonstration. Are we together? Remember, we are still learning about what? Different methods of preparing what? Oxygen in what? In a lab. The third method, we are going to discuss this. We are going to discuss the first method and second method in one session. So this is one session, this is another session. And we'll see how the NECTA exams for the Form 2 are being asked from those concepts. The third method is we can prepare also oxygen from thermal. Remember, the word thermal means what? Heat, right? Thermal decomposition. We prepare oxygen from thermal decomposition of what? Of metal peroxide. Thermal decompositions of metal peroxide. Say thermal decompositions of metal peroxide.
Thermal decomposition of metal peroxide.
Thermal decompositions of metal peroxide.
Thermal decomposition of metal peroxide.
We are not going to discuss this method according to the syllabus. It doesn't mean that I don't know, I know it. But the syllabus does not allow me to teach the Form 2 students on how to prepare oxygen by using this method. These two methods are enough, and even are more than enough. You will learn these two methods for your entire ordinary education level. Okay. So thermal decompositions of what? Metal peroxide. Say metal peroxide.
Metal
So I
peroxide.
want to give you the question, okay? Because we are not going to discuss the weight equation. I want just to give you the idea. Say weight equation. Say weight equation.
Why the equation?
One of the metal, when you say metal, we have different metals, but the preferred one is barium. Say barium.
Barium.
Okay, so we say that when we take barium, we oxidize it, we get barium oxide. When you take barium oxide, we oxidize it, and hence we get barium oxide or barium dioxide. And then when we heat this barium dioxide, we get the barium oxide plus what? Oxygen gas. Okay. So the word equation, we say that we take barium oxide, we react with what? With oxygen, and then we form intermediate product. Intermediate what? Barium oxide. Intermediate, let's say intermediate products in general. Intermediate products means that these are the not desired products. And when we take these intermediate products, we heat them. So you know now the meaning of this symbol. We are going to get what? Barium oxide plus what? Oxygen. Plus oxygen gas. So here we see that we are going to have two equations. We have two reactants react together to form intermediate product, and then we heat that intermediate product, then we get the end product, which is barium oxide and what? And oxygen gas. Stop writing if you are writing. Listen, so now this is the chemical equation. We write chemical equation by using what? Symbols. Okay? Barium, say barium.
Barium.
The chemical symbol of barium is this one, capital B and D, beta A. And then barium oxide. So we have barium oxide. This one react under presence of what? So let me see the conditions. Yes. Okay, from what? This is oxygen from air. So this is from air. What is this? Oxygen gas, right?
Yes.
So when barium oxide, this is called barium oxide. Say barium oxide.
Barium oxide.
Okay, react with oxygen from air. Then we get barium oxide again, but of another form, barium oxide as intermediate product. Kwa hii ni manake ni tunda au tunasema kwamba ni kinachozalishwa katikati wakati reaction haijakamilika, kwa sababu nataka kuandaa oxygen. Sasa ili tuandae oxygen lazima siku zote hiyo oxygen inayoandaliwa iwe upande wa product, yani iwe ni matokeo. Sawa? Kwa hii ni intermediate product. Maana kwamba inatoka kwenye kwamba barium oxide, nataka tuitoe hiyo oxygen hapa tuzitenganishe, au nataka tutengeneze oxygen. Kwa hii ni oxygen ambayo iko hewani sehemu kama hapa, right? Inaitwa oxygen from air. Kwa tukichukua barium oxide tukafungua chopa yake, itachukua oxygen kutoka kwenye nini? Hewa. Itatengeneza barium oxide ya namna hii ambayo hii chemical formula yake sio sawa na hii hapa. Sawa? Baada ya hapo we take this barium oxide, say barium oxide. Okay, now ngoja niondoe hii, tutakufundisha baadaye. For hii barium oxide we heat. You know the function of heat?
Yes.
To speed up the chemical reaction, right? Yes. So when we heat, we are going to have 2 moles of 40 of barium oxide. Kwa napata barium oxide hii hapa kama upande wa product, jumlisha na nini? Oxygen gas. Kwa hivyo, kwa hapa na barium ngapi? Kwa na balance. Tutafundishana mambo ya balance equation baadaye. Na barium ngapi? 2. Hapa tunayo 1. Kwa tunaongeza 2. Huko na barium ngapi? 2. Na hapa na barium ngapi? 2. Hapa na oxygen ngapi? 2 mara 2, 4. Na hapa na oxygen ngapi? 2. Jumlisha na hizi 2, 4. Kwa namba za oxygen za upande wa kushoto ni sawa na namba za oxygen za upande wa kulia. Tutafundishana baadaye mambo ya balanced equation. Ndio maana kuna ile topic ya mwisho inaitwa chemical equation. Tutafundishana mambo ya balance equation. Ila kwa hapa wewe usiumize kichwa kwamba mimi nafanya nini. Right? Wewe unachotakiwa tu kukumbuka kwamba one of the methods of preparing what? Oxygen gas is by thermal decomposition of metal peroxide. That's all.
The meaning of barium.
Barium it's a metal. It's an element. Like oxygen, like nitrogen, like potassium. Ni element moja hapo ambayo haiko kwenye ule mtiririko wa elements 20. Ziko element zaidi ya 100 duniani zinazojulikana. Ila kwa O level au kwa kidato cha kwanza mpaka cha 4 tunawafundisha element 20. Ukienda kidato cha 5 na cha 6 au ukienda diploma au stashahada tunaita, utajifunza element zingine zilizobaki. Right?
Yes.
Yeah. So one of the elements that you are going to learn is called the barium. Ni element ambayo iko kwenye group 2. Kwa hiyo sifa zake zinafanana na calcium. You know calcium?
Yes.
Beryllium. You know magnesium? Manake ziko kwenye group moja na barium.
What about boron?
Boron? Boron is group 3. Okay, so that is all about barium. So when you say barium, don't think that there's a relationship between bariums and beryllium and the boron because all of them start with B. It doesn't mean like that. Barium is barium, and the naming of the elements also sometimes honor the person who discovered it. These elements have been discovered by the scientists. So some of the elements are given the names of the people who discovered it, of the scientists or chemists who discovered it. Are we together?
Yes.
Yeah. So, for example, you have what Newton's law, first Newton's law, second Newton's law. So that's the honor of who discovered it. Similarly, even in chemistry. So you can maybe you have been confused on what are these 2 much details. But the thing which I want to ask you to bear in your mind, one of the methods of preparing what oxygen gas is thermal decomposition of metal peroxide. That's all. You will understand everything I've written from here to here slowly, as long as we go. When you get into Form 4, it's become like a very simple. Just spend 1 minute to understand from here to here. Okay?
Yes.
Are we together?
Yes.
Okay. So that the first what? Is it the fourth or third method, right?
Yes.
Okay. So we mentioned the first method of preparing oxygen. So the first method, we say that fractional distillation. fractional distillation of air. Fractional distillations of air, but these are if oxygen gas is required in large quantity. Oxygen air is required in large quantity. So this is the first method of preparing what? Of preparing oxygen gas in laboratory, right? The first method is called what? Fractional distillation of what? Of air. But this method will be effective if oxygen is required in large quantity. Kama unahitaji oxygen katika kiwango cha juu, manake njia hii ya fractional, say fractional distillation.
Fractional distillation.
Manake distillation tunasema kwamba tutasoma huko mbele nini maana ya distillation, lakini njia ambayo unayokuta tunachukua hewa alafu hewa kama hapa, manake hapa kuna hewa ambayo ya kiasi kikubwa. Kwa tukichukua tunaweza tukachukua oxygen kutoka kwenye hewa. Kwa sababu tulisema kama unakumbuka oxygen inachangia asilimia ngapi? 21 ya hewa. Kwa manake tukichukua lita 5 ya hewa, manake asilimia 21 lita 5 tutapata nini? Oxygen. Sasa hii ndio njia mojawapo ya kuita fractional distillation. So just to end this session, kumalizia kipindi, so to end, we say that according to the chemistry syllabus for ordinary secondary education of Form 1 through Form 4, we have to teach students of Form 2 the first and the second scientific method of preparing oxygen in laboratory. So we are going to teach you how we can prepare oxygen by the method of decomposition of hydrogen peroxide by using manganese for oxide, and also we are going to teach you preparing oxygen in laboratory by using the method of thermal decomposition of potassium chlorate, right? Yeah, not potassium nitrate. Say that we are not going to use that method. So to end this session, it's enough. Okay, it's enough for today. See, it's enough for today. So you have to So to end this session, let me leave the homework for you. And you have to make sure that you don't miss session 3, and I will teach you the first method of preparing oxygen. So this is homework. In short, just write HW, and this is homework 2. Make sure that you do this question because it will prepare you in the next session. This is example 1. Example 1. This is example 1. You have to refer. I took this example from nectar. Say nectar Yes, I took this example from nectar from past paper. Use nectar from 2014, and this was question 4 from an A. Okay? Because I will mention where to I take the question. Question 6 state that draw a diagram to show laboratory preparation of oxygen using hydrogen peroxide. Using hydrogen peroxide. In the diagram, label all the compounds. Label all the compounds and elements involved in the preparation. So if you do this, you're going to have 6 marks. So if you have 6 months and other 6 months and other 6 months, you find you are in 50. Or maybe you find that you have now 80 out of 100. So let me read the questions, the homework. So this is the homework. Please make sure that you do before we meet in session 3. And you have to submit, if you're online, you have to submit your homework through the comment section, as I told you. So example 1, refer nectar from 2. I took this question from this book, from 2 Chemistry Review, questions and answers from 2003 to 2019. And you can order this book, we can ship in any region of Tanzania, including Unguja and Pemba, right? So you can order this book, I can ship. And I'm not selling it. I want to equip all my students, because in every session, I think that in all the sessions of chemistry, for the Form 1 and Form 2, I'm going to use this book, right? In order to prepare you, because you know that when I'll be teaching you only the concept without questions, you can fail, not because you don't know the answer to the questions, but because you're not experienced to see how questions are being asked. So let's read these questions together. Stop writing if you're writing. Draw a diagram to show a laboratory preparations of what? Of oxygen. Then the questions was very specific, not general. Because how many methods I taught you of preparing oxygen? 4. Decompositions of what? Hydrogen peroxide by using what? Manganese 4 oxide. That's the first method. The second method, same decompositions of what? Potassium chlorate or potassium nitrate. Right?
Yes.
The third method, we say that same decompositions of what? Of metal hydroxides. That's the third method. The first method is still on the blackboard. Fractional distillations of what? Of air. Right?
Yes.
So the question, did the question ask the first method, second method, or third method, or fourth method? The first method. Where did it ask? Using hydrogen peroxide. So the first method, it's the one that talking about hydrogen peroxide. Then you've been asked again, when you draw that well-labeled diagram, in the diagram, label all the compounds. So you have to label the compounds and the elements involved in preparation. And you have 6 marks. So you have to draw the set of experiment and then you have to label. Drawing without labeling is nothing in science. So whenever you draw, you have to label. But sometimes you can be given, in some of the questions, you can be given a drawing, and then you'll be asked to label. So you have to understand, right? And sometimes you can be given a drawing, and then you'll be asked, this is the experiment of preparing gas cube, right? And then you'll find some other questions. Mention gas cube. So if you don't know the laboratory state of preparing oxygen, preparing hydrogen, then you'll get confused. But in most cases, we prepare in Form 2, we test the students on preparations of oxygen or preparations of hydrogen in most cases, right? So for oxygen, we have two ways of preparing it: decomposition of hydrogen peroxide and thermal decomposition of potassium chloride, right? For hydrogens also, when we go to chapter 2, we'll see what are the methods. So, so you see from here, to me, that if you know the answer of these questions, you have 6 marks. So the exam of Form 2 of NECTA, Form 2, is not tough as students used to worry, or they used to be afraid that and think that the chemistry exams is difficult. You see now we are still beginnings of chapter 1. Then we are start tackling or approaching or answering the next exams. Don't think that you will answer the next exams when you have finished all the 7 chapters. No. Whenever you cover one chapter, you have to see how questions are being asked. Because one of the specific objectives of Tanzania Online Ordinary Secondary School is really to prepare our students to understand and to pass the continuous assessment, the midterm testing, the terminal exams, the annual exams, or the pre-mock exams, or the mock exams, the national exams. So those are all our specific objectives, right? But remember that our main objective is to challenge every student to think how you can take these classroom instructions to solve a problem. Because there's a problem that's waiting you to solve. Everybody in this world has a particular problem to solve. So now if you're doing or you're learning chemistry, you have to ask yourself, how can I apply this information? What problem can I solve specifically by this information? Maybe you can say that, okay, myself, there is a scarcity, there's no any laboratory, maybe in my village, right? Or maybe in my district, there's no any free laboratory. I'm going to establish a laboratory and teach students on how to prepare chemical elements, so prepare oxygen gas, prepare hydrogen gas. That's a problem you're solving, right? So don't think that it will solve a problem maybe until you change maybe something, or you change the soil into water, no, or water into soil. Don't think that such kind of the problems that you're going to solve. Don't think that the problems that you have to solve is actually very complex. You can solve even a simple problems, and then you help the humanity. And also you find that you leave the legacy when you die. Are we together? So make sure you do the homework. That is just extra information. But I invite you in the next session, session 3. This is the end of session 2. Actually, I'm not happy because I still have a lot of information to tell you. So I don't want to end this session, but according to time, it's enough for you. I cannot overdose you if I continue. So don't miss session 3. I still have a lot of information. I will answer this question, and then you will check yourself if you got it or you missed it. Don't worry to do mistakes in learning. Even myself, what I'm teaching you is 80% of the mistake I did when I was in ordinary level. So it means that 20% I was right, so 80% I did mistakes. But I learned from those mistakes, and that's why I have a strong desire to make sure that I tell other students of present and future generations about the mistakes which I did myself, so they cannot do the same mistake as I did. All right? So, if please, just to register into these schools, make sure that you click the buttons of subscribe so you get notifications once we have recorded the session 3. And that session 3 will be titled as Laboratory Preparations of oxygen by using decomposition, or by the method of decomposition of hydrogen peroxide by using manganese 4 oxide as catalyst. So stay tuned. Enjoy the beauty of chemistry. See you in the next session. have to say thank you.